8.8 million pounds of thrust. One single purpose, to send humanity back to the moon and then to Mars. This is the Space Launch System, the most powerful rocket ever built. And right now, it is being assembled, piece by piece. It all begins here, at the Michoud Assembly Facility in New Orleans, Louisiana. Inside a hangar the size of 3 football fields, Boeing engineers are building the largest rocket stage NASA has ever designed. 212 feet tall. A colossal cylinder of aluminum and ambition. The liquid hydrogen and oxygen tanks are built in sections. Each barrel is welded with millimeter precision by automated friction stir welding machines. A single flaw in the weld, and the entire stage could be compromised. There is no room for error. Support structures the size of buildings hold the stage during assembly. Each component weighs tons. Crews work around the clock, 7 days a week. This is not just a rocket. It's a cathedral of metal, raised by human hands. Now comes the critical moment. The 2 largest sections of the core stage must be joined together. The hydrogen tank dome approaches the main barrel, inch by inch. An operation that takes hours, and demands the patience of a watchmaker. 2 giant cylinders, face to face. An army of engineers watches every angle. The edges must align within a tolerance of less than 1 millimeter. When the sections finally meet, the core stage takes shape. With every section welded into place, the core stage rests on its side. 212 feet long. 27.6 feet in diameter. When fueled, it will carry 730,000 pounds of cryogenic propellant. Inside Boeing's Michoud factory, the core stage dominates the floor like an ocean liner parked inside a garage. Forklifts look like toys beside it. Human beings are tiny specks at the base of this monument. But a giant fuel tank alone goes nowhere. To turn this cylinder into a machine capable of escaping Earth's gravity, it needs hearts. 4 hearts, to be exact. 4 engines that once flew on the space shuttle. Now reborn, for a new era. The RS-25s. Each one generates 212,000 pounds of thrust. Together, nearly 900,000. But before they fly, each engine must prove it is worthy. And the proving ground is Stennis Space Center, where fire meets science. Ignition. A fireball at 6,000 degrees Fahrenheit erupts inside the test stand. The ground shakes. The air trembles. Hydrogen and oxygen collide at absurd pressures, generating a plasma jet that could melt steel in seconds. And the engine holds. From the air, the true scale reveals itself. A steam cloud the size of a stadium rises over the Mississippi swamp. Each test lasts hundreds of seconds. Each second generates enough data to fill libraries. If the engine survives, it earns the right to fly. Back at Michoud, the certified engines are installed one by one into the base of the core stage. Boeing technicians work in tight spaces, connecting hundreds of cables, fuel lines, and sensors. 4 engines. Thousands of components. But the RS-25s alone are not enough. To rip 5.7 million pounds off the launch pad, the SLS needs raw power. It needs the solid rocket boosters. 2 beasts of solid fuel that will deliver 75% of total thrust. Each booster stands 177 feet tall. Built-in steel segments, packed with an explosive mixture of ammonium perchlorate and powdered aluminum. And once ignited, there is no shutdown command. They burn until they are empty. The segments are manufactured in the deserts of Utah, by Northrop Grumman. Once filled and sealed, they are shipped by rail across the country. Each railcar carries a cylinder of controlled destruction. Specialized haulers crawl across desert highways. Oversized load. All headed to the Kennedy Space Center in Florida. A journey of thousands of miles, at walking speed, for hardware that will burn in 126 seconds. Meanwhile, in Huntsville, Alabama, the Marshall Space Flight Center builds the launch vehicle stage adapter. A cone-shaped structure that connects the core stage to the upper stage. Every weld, every rivet, every bolt, must be flawless. The golden cone travels through the streets of Huntsville in a special convoy. Escort vehicles. Police officers. Traffic lights overridden. A rocket component crossing an American city, like a royal procession. In the background, a Saturn V from the 1960s watches in silence. The past, saluting the future. At sunset, the adapter reaches its destination. Engineers and program managers watch the arrival like proud parents. Inside, the cone will receive thermal insulation and one final inspection before continuing its journey. Yellow spray-on foam insulation covers every inch of the structure. It is not aesthetic. It is survival. The foam protects the metal. The metal protects the mission. The mission protects the dream. Night shift. Under artificial floodlights, crews strap cargo onto heavy-duty flatbeds. Every component of the SLS travels separately. By land. By sea. And by air. The Orion Stage Adapter. The structure that will connect the Orion capsule to the cryogenic propulsion stage. A smaller piece, but no less vital. It will also house 13 CubeSats destined for deep space. Inside a clean room, the adapter is hoisted by precision cranes. Technicians in white guide the piece with ropes. Every movement is calculated. Every gesture, rehearsed. There are no second chances when handling flight hardware. Wrapped in bright pink protective plastic, the adapter exits the factory on a NASA truck. It looks like an oversized birthday present. But its destination is not a party. It is the edge of space. The Super Guppy, the strangest cargo aircraft in the world, swings open its fuselage like an enormous jaw. The pink adapter slides into the belly of the beast. A scene that looks like fiction, but it is terrifyingly real. The aircraft lifts off gently, carrying its precious contents over the Gulf of Mexico. Destination: Kennedy Space Center, Florida. Where every piece of the puzzle will finally come together. In Florida, the booster segments arrive by train and truck. In the distance, the launch pads rise against the horizon. This place sent men to the moon. And it is about to do it, again. Inside the vehicle assembly building, the tallest single-story structure on Earth, each component will be stacked onto the mobile launcher platform. First the boosters. Then the core stage. Then the upper stage. The interim cryogenic propulsion stage. Built by United Launch Alliance, this upper stage will perform the final burn that sends Orion beyond Earth orbit. A single RL-10 engine. Quiet. Precise. Lethal. The ICPS rolls down the flat roads of Cape Canaveral in convoy. This is the last component to arrive. When it is placed atop the core stage, the SLS will be complete. 322 feet tall. Ready to roar. The completed SLS reveals itself. The orange core stage dominates the center. The two white boosters embrace its flanks. At the top, the Orion capsule awaits its future crew. Launch Complex 39B. The same ground that trembled beneath the Saturn V. Now, a new era is about to begin. The SLS is in position. The tanks are full. The countdown has started. All systems are go. Flight controllers confirm every parameter. The world holds its breath. 10, 9, 8. Main engine ignition. The four RS-25s roar to life. 6,000 degrees Fahrenheit. But the rocket does not move. Not yet. It waits for confirmation that all engines are nominal. Booster ignition. Now. 8.8 million pounds of brute force against gravity. The rocket breaks free. The concrete cracks. The air tears apart. And the SLS rises. Slow at first. Then faster. And faster. The light is so intense it outshines the Florida sun. The sound arrives seconds later. A deep, primal roar you do not hear. You feel it. In your bones. In your chest. In your soul. The rocket punches through the sound barrier. Max Q. The moment of maximum aerodynamic pressure. The vehicle shudders. And then, it breaks through. The sky begins to darken. At 126 seconds, the boosters separate. The core stage continues alone. The atmosphere thins. The curvature of the Earth appears. The SLS crosses the boundary into the unknown. Seen from space, the exhaust trail cuts through the atmosphere like a white scar. Florida falls behind. The ocean shrinks. And the Orion capsule rides atop the upper stage, ready for the moon. The upper stage engine ignites one last time. The translunar injection burn. 24,000 miles per hour. Fast enough to escape Earth's pull. Separation. The core stage drifts away. The Orion capsule deploys its solar arrays and orients itself toward deep space. Below it, the entire Earth fits inside a window. Built by thousands of hands. Driven by millions of dreams. The Space Launch System is not just a rocket. It is proof that when humanity decides to go somewhere, nothing in the universe can stand in the way.